Good morning, friends. This is Engineer Imran Aziz. I am again here on my YouTube channel with a new topic. It's building construction technology, and under this topic, we will be discussing the foundation part of the building. So, I will be presenting today again as a part one of this topic, and it will definitely help the engineers like you prepare for competitive exams, your interviews, and university tests. And remember, the correct answers will be clearly highlighted so that you can review them effectively. So let's get started with this chapter, part one. And question number one for today is number one: the lowest part of a structure which transmits loads on soil is known as. You can see the picture of that part. It's the lowest part of the structure which transmits the load of the structure on soil. Number A, superstructure. B, plinth protection. Number C, foundation. Number D, basement. Yeah, of course, the lowest part of any structure is the foundation. Even basement is not the lowest part. Basement has its own foundation. So foundation is correct answer, which is C. Question two, Grillage foundation. What is Grillage foundation? Number A option is light and economical. B, does not require deep cutting as the required base area with required pressure intensity is obtained at a shallow depth. Number C is used to transfer heavy structural load from steel columns to a soil having low bearing capacity. D, all of the above. So option A, B, C are correct. So option D is the answer, which is all of the above. It's light and economical. It does not require deep excavations. The intensity of the pressure can be obtained at a shallow depth, and it has the combination of the steel columns and concrete. So option C is also correct. So option D is all of the above, which is correct option for this question. Now we will discuss what is grillage foundation and why they are used and where they are used. I will show you the picture of the grillage foundation as well, so that you should have some background knowledge before discussing this question or this topic. So, grillage foundation is basically a type of shallow foundation that uses multiple tiers of steel, timber, or concrete beams in a grid pattern to distribute heavy loads over weak or low bearing capacity. So remember, first requirement or the first prerequisite why a shallow foundation or the grillage foundation is used is the low bearing capacity or weak bearing capacity of the soil. Where we encounter such type of soil which has low bearing capacity, so designers recommend the grillage foundation in that area. It's basically a combination of concrete and steel. You can see in this picture, it's a combination of steel and concrete and wooden beams. So the load should be transferred not only through the concrete but uh, is bared through steel columns as well. So you can see in the picture there is steel uh, beam on the top, column on the top, and then we have base plates distributing that load to the maximum area. Then we have lower base plate, we have upper base plate, concrete, cement concrete as well. So it's a combination of both. Secondly, it transfers load, a heavy load of the structure from column or piers to a larger area of the soil, which helps prevent settlement and ensure stability. Thirdly, commonly used for bridges and towers, industrial buildings, and electrical transmission lines. So these are its utilities. It is used for towers, bridges, factories or industrial areas, as well as heavy transmission lines, where normally we encounter the low bearing capacity soil. So the designer prefer to go for grillage foundation. It's the most cost effective than other methods like piling or etc. of raft foundation. It's a effective solution and adopted when deep excavation is not feasible. So this foundation is given at shallow depth, and this is the normal picture of this foundation, so you can have an idea. Then we have question number three. For providing raft foundation, the following activities are involved. So here is a sequence of various activities which are done for raft foundations. Number one, ramming of foundation bed. Number two, excavation of soil up to required depth. Number three, laying of reinforcement over the foundation bed. Four, curing of cement concrete placed over reinforcement. Number five, pouring of cement concrete over the reinforcement. The concrete sequence is A 1, 2, 3, 4, 5, B 5, 4, 3, 2, 1, C 2, 1, 3, 5, 4, D 3, 2, 5, 1, 4. Option C is correct, which is 2, 1, 3, 5, and 4. So first of all, we do excavation of the soil. For the raft foundation, we do excavation of the soil up to required depth. Then we do ramming of that bed, foundation bed. Then laying of reinforcement over that rammed bed. Then we have pouring of concrete over the reinforcement, and then lastly we do curing of the cement concrete placed over the reinforcement. So option C is correct. Order number C is correct, which is 2, 1, 3, 5, and 4. Then we have question 4. Raft foundation are generally preferred to when the area required for industrial footing is more than the area required for individual footing is more than A 25% of the total area, 30% of the total area, C 40% of the total area, D 50% of the total area. So raft foundations are preferred when the area required for individual footing is more than 50% of the total area. Option D is correct. And then we have question number 5. During percussion drilling, number A, caving or mixing of strata are caused in soil, soft soil or cohesive soil. Number B, groundwater observations are hindered due to entry of slurry in the soil below the bottom of the hole. The soil to be the soil to a considerable depth below the bottom of the hole gets disturbed. D, all of the above. So in case of percussion drilling, all these options are correct. So option D is the answer. Solid core of rock is formed inside the cylinder in case of number A, diamond drilling, number B, percussion drilling, wash boring or auger boring. So in case of diamond drilling, we observe that a solid core of rock is extracted in the cylinder, which is being used for the drilling. Option A is correct. Question 7. The auger boring are not common. Number A in soft soil. Number B in soil that require lateral support. In cohesive soil, none of the above. Option B is correct, which is the auger boring are not common in soil that require lateral support. Question number 8. Pick up the commonly adopted geophysical method in civil engineering from the following. Number A. Electrical resistivity test or method. Number B. The seismic method. Both A and B or magnetic method. So both A and B are correct. We normally encounter or uh, go through these methods in the field, which is electrical resistivity method. We do this type of method for the water testing or the water availability in some area, and seismic method is used for earthquake building design. So uh, both option A and B are correct. Number 9, for heavy embankments and dams of height h, the depth of exploration of soil should not be less than number A, h by 4, h1 by 2h, CH, D2h. For heavy embankments of the dam of height h, the depth of exploration of soil should not be less than 2h. So it should not be less than double the height of the embankment. Option D is correct. Then we have question number 10. Rotary drilling hinders the groundwater observations and preliminary tests. B is not economical for holes of less than 10 centimeter. C is not suitable for deposits containing very coarse gravel. D all of the above. So option D is correct. Rotary drilling is not suitable for deposits containing very coarse gravel. It's not economical for a hole of less than 10 centimeter, and it obstructs the groundwater observations. So option D is correct, which is all of the above. Number 11. In Grillage foundation, a minimum of 15 centimeter cover is provided on number 8 lower beam of lower tier, the ends of external beam, upper flank of top tier, or none of the above. Option A is correct, which is lower beam of the lower tier. This is regarding the end of the foundation. They provide 15 centimeter cover. Option A is correct. Question number 12. The maximum bearing capacity of soil is that of number A, loose, fine sandy soil, dry, coarse sandy soil, C, hard rocks, black cotton rock. So maximum bearing capacity is for hard rock, while the minimum bearing capacity is for black cotton soil. So for this question, option C is correct. Question 13. Raft foundations are used for number A, counteracting the hydrostatic effect. B, providing increased area of foundation over poor bearing capacity of the soil. C, spanning over small, soft or loose pocket. D, all of the above. So raft foundations are normally provided where we encounter the hydrostatic effect of water or underneath soil, providing increased area of foundation over poorly bearing capacity. Yes, it provides increased area. Spanning over small, soft or loose pocket. Yes, this is also correct. So option D is correct for this question. Question 14. To support a heavy structure in sandy soil, the type of foundation generally used is number A, combined footing, raft foundation, pier foundation, strap footing. To support a heavy structure in a sandy soil, the type of foundation generally used is pier foundation. Option C is correct. Question 15. The depth of groundwater table may be ascertained by number A, standing on the well in the vicinity, B, measuring the depth of water in the well, looking through the well, none of the above. So, depth of the groundwater in that area can be measured through the depth of water in any well. So, as the water maintains its level, so depth of the water in the well will be the depth of the groundwater table. Question 16. In clay soil, the swelling and shrinkage characteristics prevail. Consolidation continues even after several years of construction. C. Differential settlement is generally prevalent. D. All of the above. So all these options are correct. That's why people don't recommend the clay soil. So option D is correct. Swelling, shrinkage characteristics prevail. Consolidation continues, and differential settlements occur anytime. So option D is correct. Question 17, the bearing capacity of piles is determined by number A, static formula, dynamic formula, pile load test, all of the above. So we do recommend all these methods. So option D is correct for this question, and bearing capacity of the piles can be determined through static formula, dynamic formula, or the pile load tests. Option D is correct for this question. Question number 18. The depth of excavation of foundation is generally measured with a number A, ranging rod, B, boning rod, C, steel tape, D, leveling staff. So for measuring the depth of any foundation, it's boning rod. Question 19. The pile provided with one or more bulbs in its vertical shaft is generally known as number A, under-ream pile, friction pile, sheet pile, bearing pile. So it's ramming piles. Option A is correct. Under ramming pile or ramming pile is the pile which has bulb type of caving at the end. So option A is correct for this question. Question 20. In soft clay of low bearing capacity, the type of steel pile generally used is number A, H pile, B, box pile, C, tube pile, D, screw pile. So in soft clay of low bearing capacity, screw pile type of steel pile generally used is screw pile. Option D is correct for this question. Question 21. Open test pit is only suitable up to the depth of number A 2.5 meter, B 2 meter, C 3 meter, D greater than 5 meter. So open test pit is made up to the depth of 3 meter. Option C is correct for this question. Then we have question 22. Rotary drilling is the fastest method in case of number A, clay soil, number B, rocky soil, number C, sandy soil, all of the above. So for all these soils like clay, rocky or sandy, the rotary drilling is the fastest method for drilling. Option D is correct for this question. Don't go for percussion drilling in case of rocks or sandy soil or clay soil. 23. Pile foundations are suitable for number A, soft rocks, B, waterlogged area, C, compact soil, none of the above. So piles are generally provided and recommended in the waterlogged soils. So option B is correct for this question. 24. Under reamed pile, under-rail piles are generally used for number A, machine foundation, number B, transmission line towers, tall structures. So all of the above are correct. Option D is correct for this question. Under-rail we already discussed. It's the pile which has the bulb type of structure at the end. So such piles are recommended for machine foundations or the transmission towers or the tall structures. Option D is correct for this question. Then we have question 25 and the last question for this part. The pile which supports the load partly by friction and partly by uh, resting on the hard stratum is called number A, bearing pile, B, friction pile, C, compaction pile, D, better pile. So it's the friction pile which partially transmits load on the underneath soil and partially on the side walls. So option B is correct for this question. So thank you for watching. You have completed building construction technology foundation part of this topic. It's part one, and we will be providing fully solved MCQs question on some other topics within this main topic in the following videos. We again urge to subscribe to CivTech Simplified for upcoming video and follow us on Facebook, Instagram, and TikTok. So thank you very much. This is the link for CivTech Simplified where you can find us on YouTube as well as on TikTok. You can also send your questions through email at civtechsimplified@gmail.com. So see you in the next video. Thank you.